Hello friends, welcome back to Civil Engineering Mastery. Today we are going to discuss a very important topic which is the earthquake design, and it is a very vast subject and also an interesting subject. So first let's start with the introduction. First let's see what is an earthquake. A sudden release of stored energy in the earth crust creates seismic waves that cause an earthquake. Simply we can say that it is the shaking of ground. So let's see in brief, it is the sudden shaking of the ground caused by the passage of seismic waves through earth rocks. In this picture you can see the building which is affected by earthquake. Seismic waves are produced when masses of rocks raining against one another suddenly fracture and slip. So as I told you before, a sudden release of stored energy in the earth crust causes seismic waves, so that creates an earthquake. So you can see from this image, so this is how the slip or fault happens, like this sliding each other, the earth crust or rock masses of rock straining each other, and then it creates a fracture and slip. So it occurs most often in narrow zones where rock masses move in relation to one another. Next, let's see what is earthquake load. It is a dynamic load which creates the vibration of structure. So when the earthquake occurs, we feel the vibration. So if it is a minor earthquake, we feel the vibration. If it is a major or severe earthquake, then the building may get severe damage or even collapse. So we have to be very careful while designing the building for earthquake. So in order to avoid the severe damage or collapse of the building. I hope any one of you might have experienced earthquake in your life. If it is so, then please do comment in the comment box name of the place, and if you know the magnitude of the earthquake, even that you can mention. It is generated by the movements of the ground. So when the building is resting on ground, if the earthquake occurs, it starts vibrating, or according to the ground movement, the building also react. Earthquake load depends on seismic hazard, parameters of the structure, and gravity load. When the earthquake load exceeds the moment of resistance offered by the structure, then the structure may collapse or even damage. Next one is objectives of earthquake design. So what is the main objective of earthquake design? To build and design and maintain structures that are capable to withstand earthquakes. So whatever the structure we are designing, that should be able to withstand the earthquakes. So to make sure that the structure will not damaged or minor shaking and will avoid serious damage or collapse in a major earthquake. As I told you before, it is a dynamic earthquake load is the dynamic load and which creates vibrations of structure. So when we are designing the structure for earthquake, so we have to make sure that structure will not be damaged in minor shaking, and it should not get collapse or severe damage in major earthquakes. Next, let's see about earthquake design philosophy. First one is minor, which occurs frequently. Second one is moderate, which occurs occasionally. Third one is strong, which occurs rarely. So let me explain you briefly about this design philosophy. So it will be very interesting to know. I hope you all are excited to know about this earthquake design philosophy. Let's see now. An average of 500 to 800 earthquake of magnitude 5 to 5.9 occurs throughout the year in the world. So as we have seen before, minor earthquakes occurs frequently, moderate earthquake occurs occasionally, and strong earthquakes occurs very rare. So here comes the conflict for the engineers, whether they have to design the building without considering the effect of earthquake, or should they design the building with earthquake proof. So this conflict arises for the engineers in design of earthquake structures. Among these two cases, the former creates a major disaster since they don't consider the earthquake effects when designing a structure. The second one is too expensive. We cannot make earthquake-proof buildings since the strong earthquakes occurs very rarely. So the design philosophy should lie in between these two cases. So here comes the solution, that is earthquake resistant structure. So we have to design the structure as earthquake resistant. So the engineering intention is to design the structure as earthquake resistant. Such structure resists the effect of ground shaking, although it may get damaged severely, it would not collapse during severe earthquake. Safety of people is assured in earthquake resistant structures, and also the major disaster can be avoided. So this is the main design philosophy of seismic design codes all over the world. Now let's summarize the earthquake design philosophy. First one is minor, which occurs frequently. In this one, the main members which carries the load should not be damaged, and other part of the building, that means the members which will not carry the load, may sustain repairable damage. Next one is moderate, which occurs occasionally. So in this one, the main members may sustain repairable damage, and the other part of the building may get damaged. They may have to be replaced after the earthquake. Next one is strong, which occurs rarely. In this one, the main members may sustain severe damage which is irreparable, but the building should not collapse. So this is the major design philosophy. I hope you understood clearly about the earthquake design philosophy. Next, let's see IS code for earthquake resistant design. So till now we had discussed about earthquake design philosophy. So from that we came to know that we have to design the structure to resist the earthquake. So first one is IS 1893 Part 1 2016, which is a criteria for earthquake resistant design of structure. This is mainly for general provisions and buildings. Next one is IS 1893 Part 2, that is criteria for earthquake resistant design of structures. This is specifically for liquid retaining tanks. Next one is IS 1893 Part 3, criteria for earthquake resistant design of structures. This is for bridges and retaining walls. Next, IS 1893 Part 4, criteria for earthquake resistant design of structures. This is for industrial structures including stack-like structures. Next, IS 13920 2016. This is for detailing of earthquake resistant structures, ductile design and detailing of reinforced concrete structures subjected to seismic forces. So these are all the codes and standards we have to follow when designing earthquake resistant structures. Next, let's see earthquake method of analysis. We have three method of analysis. First one is externally applied load, and the second one is behavior of structure. According to the behavior of structure we have to analyze, and third one is type of model we choose. This externally applied load further can be divided into static analysis and dynamic analysis, and behavior of structure can be further divided into elastic analysis and elastic plastic analysis. Let me write here, this can be further divided into static analysis and dynamic analysis. Similarly, this behavior of structure can be divided into elastic analysis and elastic plastic analysis. This type of model can be divided into 3D, 2D and 1D. Static analysis can be further divided into linear static analysis and non-linear static analysis. Linear static analysis can be called as equivalent static analysis. Non-linear static analysis can be called as pushover analysis. And next one is dynamic analysis. This is also divided into linear dynamic analysis and non-linear dynamic analysis. This one is called response spectrum method. Linear dynamic analysis is called response spectrum method, and non-linear dynamic analysis is called inelastic time history analysis. This is also a vast subject in earthquake analysis. So let's discuss in detail about each method in the upcoming videos. So friends, I hope you all like this video. Please do comment in the comment box and don't forget to subscribe this channel for more videos. So you have to understand the earthquake design philosophy very clearly. So if you have any queries regarding that, you just post in the comment box. I will upload one new video exclusively for earthquake design philosophy so that you can understand still better. Thank you friends. Thank you for watching.